deep divers. We've got a real cosmic riddle for you today, something that's genuinely challenging some pretty fundamental scientific ideas about how our universe even began. We're going way beyond the usual headlines, diving deep into the universe's earliest moments. And this isn't just, a minor tweak. We might be looking at a whole new type of cosmic object, something that could rewrite the story of supermassive black holes, how they got so big, so fast, and maybe even the story of galaxies, of everything, really. Okay, let's unpack this. First up, we need to talk about the tool making this possible. NASA's James Webb Space Telescope, the JWST. It's basically humanity's most powerful time machine.
Right.
It lets scientists look back billions and billions of years, almost to the dawn of space itself. And ever since it started sending back data, well, the images have been mind-blowing, like opening windows onto the universe when it was super young, chaotic, completely mysterious. The sense of awe when those first images came through was palpable, just incredible. But then back in 2022, something really weird started showing up in that early data.
Scientists spotted these tiny little dots scattered across the very distant universe. But they were incredibly vivid, really red. And here's the thing, they weren't just stars. They didn't look like normal baby galaxies either. They were something else, something potentially revolutionary. So our mission today, figure out what these little red dots, as they're called, actually are, and what they're telling us about how the universe grew up.
It really is fascinating, and you saw the scientific community just jump on this almost immediately. Teams all over the world, including a key group from Penn State, started digging into these anomalies. Because the initial data, well, it showed these dots were shining incredibly early. We're talking just 500 to 700 million years after the Big Bang. Now, you have to pause and think about that. That's really, really early in cosmic terms. It made them seem, well, almost impossibly mature for that point in time.
Impossibly mature. So mature in a way that just didn't fit with the standard picture, the established models of cosmic evolution. So what was the first, maybe most obvious idea? If they were somehow mature objects, what did scientists think they might be looking at?
Right. The initial thought, the sort of simplest explanation was, okay, maybe these are actually fully formed galaxies. But if they were mature galaxies appearing that early, it would mean the universe is building these huge structures way faster, and maybe much more densely than any of our cosmological models allowed for. It painted a picture of the early universe as this incredibly busy, hyper-efficient galaxy factory, much faster than we thought.
So our understanding was basically, whoa, hang on, galaxies shouldn't be this developed yet.
Yeah.
And that's where they got that really dramatic nickname, isn't it?
Exactly. That's precisely why they started calling them universe breakers. Because if that interpretation was right, if these were fully fledged galaxies so soon after the Big Bang, it would literally challenge, maybe even break, the standard model of cosmology. The very framework we use to understand how structures like galaxies form and evolve over cosmic time. It demanded a major rethink.
Okay, but science rarely stops at the first, most dramatic answer. As researchers looked closer, things started to unravel a bit for that universe breaker galaxy idea, right? They dug into the specifics of the light, the spectra, and the story got, well, even stranger.
That's right. It became a real puzzle because, yes, these things were incredibly bright, super luminous, and brightness usually implies a lot of mass, like millions, maybe billions of stars packed together. But when they analyzed the light in detail, the specific colors, the signatures JWST could pick up there, it just doesn't look like a typical galaxy's light. The numbers didn't add up. It was like seeing this blazing bonfire. But the data said there wasn't enough wood, not enough normal stars to fuel such a fire. The expected populations weren't there.
Right, the brightness was way up, but the ingredients didn't match. I remember seeing that quote from Bingji Wang, the NASA Hubble fellow, saying something like, "The night sky of such a galaxy would be dazzlingly bright if it were made of normal stars." But the data wasn't showing that kind of stellar collection.
Precisely. The detailed spectral data kept saying, nope, that's not it. It wasn't matching a collection of stars, young or old. And that forced scientists to think outside the box, to really question their assumptions about what could possibly shine so brightly, so redly, so early on. And this is where Joel Lija from Penn State, his team had this key insight.
Yeah, he described it really well. He said, "We looked at enough red dots until we saw one that had so much atmosphere, it couldn't be explained as typical stars we'd expect from a galaxy." So much atmosphere. That points away from a collection of stars towards something singular, doesn't it?
Exactly. That was the crucial step. It led toward what they called the elegant answer. Maybe it's not a tiny galaxy packed with lots of separate, cooler stars. Maybe, as Ligia put it, what they were effectively seeing was one gigantic, very cold star. Not literally a star like our sun, but a single, huge, coherent object. And that was the breakthrough.
Okay, so they ruled out early galaxies. They ruled out collections of normal stars. Where did that lead them? What's the really revolutionary idea now emerging for these red dots?
Well, the leading hypothesis, the one that seems to fit this strange data best, is that these could be the very first observed examples of something entirely new, something theoretical physicists had speculated about but we'd never seen. They're calling them black hole stars.
Black hole stars. Okay, that name definitely grabs your attention. It sounds paradoxical.
Like, my first instinct is to picture a regular star with a black hole somehow inside it, which feels wrong. Can you help us visualize what this actually means, this gigantic sphere of gas with a black heart?
Yeah, it's a concept that really bends the mind because it's so different from normal stars. Okay, so picture this. An enormous object, way bigger and more spread out, more diffuse than a typical star. It's basically a giant cloud, a sphere of dense gas. Think of it like a star's atmosphere, but vastly larger. Now, at the very center of this huge gas ball, there isn't a core undergoing nuclear fusion like in our sun. Instead, there's a supermassive black hole. And this black hole isn't just sitting there, it's actively feeding. It's consuming the gas from this enormous envelope around it. And that process, the accretion of gas onto the black hole, is what powers the object. It releases tremendous energy, making the whole gas cloud shine.
Ah, okay, so the light isn't from fusion, it's from the black hole eating its own atmosphere. But it's not shining like we usually imagine black holes shining, right? Not with super hot X-rays.
Exactly. That's the key difference and why they look red and cold. Usually, gas falling into a black hole gets incredibly hot, millions of degrees, and radiates high-energy light like X-rays. But in these black hole stars, the surrounding gas envelope is huge and relatively cool. It's mostly dense hydrogen gas, maybe just thousands of degrees, not millions. So as the black hole feeds and energizes this envelope, the gas glows. But it glows primarily in red and near-infrared light. It's this specific cold, chilly hydrogen signature, this distinct crimson glow that JWST detected. It's clearly unlike a normal star or a typical active black hole.
Here's where it gets really interesting, because if this is right, these aren't just weird objects, they're potentially solving a huge problem. They could be cosmic turbochargers, right? Speeding up black hole growth in the early universe like nothing else.
That's the major implication, yes. It suggests a way for supermassive black holes to grow incredibly rapidly, much faster than we thought possible, just by merging or consuming stars alone. These objects could be the mechanism.
Let's focus on one specific example that really seemed to clinch it, the cliff. JWST pointed at this particular red dot in July 2024, and the data was apparently pretty spectacular.
Oh, absolutely. The cliff was a game changer. Its spectrum, that light fingerprint we talked about, was just unambiguous.
Yeah.
The signal basically screamed, massive single object. It wasn't subtle. What's fascinating here is that the data was so clear, yet so weird, it didn't fit any of the existing models comfortably. It really pushed things.
And what did it reveal specifically? What did the cliff's light tell us it wasn't and what it was?
Well, it definitively wasn't a collection of stars, not like an early galaxy cluster. The light signature was consistent with one enormous object. Essentially, a supermassive black hole in its very early stages, already huge, wrapped in this giant cocoon of hydrogen gas. It was actively swallowing that gas, feeding itself, and the whole enormous structure was glowing with that characteristic cold red light visible across billions of light years. Anna de Graaf from Max Planck really summed it up well. She said the cliff data basically forced them back to the drawing board. The traditional models just couldn't explain it. They were broken. So scientists had to start thinking in fundamentally new ways about how the first massive objects formed. It's moments like these that drive science forward.
Okay, so we've got these potentially revolutionary black hole stars, but let's ask the big question. So what? Why does this discovery matter to, people beyond astrophysicists? Why should you listening care about red dots and black hole stars?
If we connect this to the bigger picture, it matters immensely. Because almost every large galaxy, including our own Milky Way, has a supermassive black hole at its core, millions or billions of times the mass of our sun. And for decades, one of the biggest puzzles in astronomy has been, how did these giants get so massive so incredibly quickly after the Big Bang? Our previous models of galaxy formation and black hole growth struggled to explain it. They grew too fast.
Right. It's like finding giant trees in a forest that supposedly only had seedlings a short time before. So could these black hole stars be the answer, the missing piece of that evolutionary puzzle? The seeds or the accelerators for these giants?
That's exactly the idea. This could be the missing link. JWST might be showing us how the universe's very first large structures were built. And maybe it wasn't through the slow, steady process of star formation and galaxy mergers alone. Maybe the universe jump-started things by forming these black hole stars first. They would have acted like gravitational anchors and energy sources, turbocharging the growth of black holes and potentially seeding the formation of the first galaxies around them. It suggests the early universe lit up faster and perhaps differently than we ever imagined. It's a genuine plot twist in the cosmic story.
Wow. It really reframes our whole picture of those first few 100 million years. And it's a fantastic reminder, isn't it, that the universe is just weirder and more creative than we often give it credit for, that the biggest discoveries might be hiding where our theories haven't even caught up yet.
Absolutely. The story we tell ourselves about how the universe grew, evolved, became the place we live in, it just got a major update. A seismic plot twist, as you said. It makes looking up at the sky, or rather looking at the data from telescopes like JWST, incredibly exciting right now.
So what's next for the red dots? Are scientists just going to keep hunting for more?
Pretty much. The plan is clear. Gather more data. Get more detailed spectra from other red dot candidates. See if they consistently show this same weird signature. Test the black hole star hypothesis rigorously. They're following the clues, letting the universe tell them what's going on. And, it comes back to what Doleto said, which I think is so important. The universe is much weirder than we can imagine, and all we can do is follow its clues. Yes, there are still big surprises out there for us. It's a statement about the process of science itself, really. Humility in the face of the unknown.
Absolutely. And you can't help but wonder, what is the next surprise Webb will uncover? Will this black hole star idea hold firm as they find more examples? Or is there another twist coming? Perhaps something even stranger that forces another rethink. It really feels like we're right in the middle of a scientific revolution. For now, astronomers, physicists, cosmologists, anyone fascinated by the big questions, we're all watching, waiting, analyzing, and we want to know what you think too. If you've got questions about this or your own wild ideas about cosmic origins, send them our way. How do you imagine the universe's earliest moments? What secrets do you think are still out there waiting? Thanks for diving deep into the cosmic weirdness with us today. Please subscribe if you haven't. Share this deep dive with anyone else who loves a good cosmic mystery. And as always, stay curious. Until next time, keep your feet on the ground and your eyes on the stars.